So we planted the strip crop of the pea, which fixes the nitrogen, and then by the time maize is coming, we harvest. That nitrogen benefit is there for the crop. So I wanted to focus on two things. Don't worry about all this graph, or graph 1 and this graph. So if you look at the graph on the top, the x-axis is peas, field peas, maize, wheat and maize. And the first one is mono, relay, mono, relay, mono, relay. What you can see is that with a relay cropping, we were able to increase the total yield. Point number 1. Point number 2 is that if you look at here, this is the carbon dioxide kilograms equivalent per ton of grain. In other words, to produce 1 ton of grain, how much carbon dioxide is emitted. So you can see that with a relay cropping, less. Nothing magic about it, but we were able to go and measure. And people said, you can't publish this in PNAS. I said, yes, we can. So we did a wonderful work and calculation, etc., clever thinking. And that's for an agronomy person to publish in a PNAS is a very good. But this paper is really worth. But I won't go. We have done things like the footprint on biomass, straw. We have done on net return. We also looked at the footprint on that. Now, the other one is, again, these are very useful for undergraduate students and master's students. Advanced in Agronomy is one of the top journals in agriculture. This is called Diversifying Crop Rotation Enhances Agro-System Service and Resilience. Again, it is available in your library. So we have done, for example, maize and spring pea in China, maize, spring wheat in China, durum wheat and winter peas in Spain, flax, which you grow in this country, chickpea in Canada. And we had done experiments, measured, etc. But if you look at this data, here, basically what we're showing is, if you look at the bottom graph, that is cereal, no legumes at all. If you look at the top graph, that is pulse durum rotation. And what is the thing is carbon dioxide equivalent per kilogram of grain. So basically, if you say this is 100%, that's only 34% reduction. Very simple, and that's how we need to show the politicians how the system can work out. Now, the next question is that, of course, quite often people ask effect of fertilizer management on soil bacterial community in agro-system across the globe. So, people are saying, oh, don't apply fertilizer. But if you don't apply fertilizer, I don't think we can feed the world. Absolutely. Of course, some farmers want to have complete. So what we did was that we got together. This is again a wonderful paper in Agriculture, Ecosystem and Environment, where what is the effect of fertilizer management on soil bacterial community in agro-system across the globe. So we used a meta-analysis which basically 0 means no change. If it goes this side, it is negative. If this goes, it goes positive. So then what we had was that we had a manure addition, organic manure, farmyard manure, mineral nitrogen, which comes from the bag, straw, and then we added that in the plots. Then we measured various things like the first aspect is that the mineral nitrogen addition. You can see that, let's go through this. So basically you will see that manure and mineral nitrogen increased and straw increased all this aspect. And if you look at here, this is the pH. So this is the soil organic carbon. So soil organic carbon increased. pH is neutral to increased, which is quite good. Then you see here, this is the total nitrogen. Then this is the microbial biomass. So basically, what we can show is that addition of organic manure has increased those. Then we looked at the human-induced drivers, anthropogenic drivers of soil microbial communities and impact on soil biological functions in an agro-ecosystem. And basically what happened here, this is in Canada before really land clearing. This is then crop rotations were introduced. Then further farmland and crop rotation. So we were able to go and measure various aspects what's going on. To summarize that, basically land management, crop design, available resources, rich farmer or poor farmer, technology applied, policies and laws of the government, environmental conditions can influence the activities of the microorganism. But for farmers, these are some of the things they can do it, make a difference. And with that, and with this, we can increase the yield or decrease the yield, modify the soil microbes, and then we can achieve the environmental influentials and economic impact, and of course, social effects. So, as a researcher, as a policy maker, one need to look at all these aspects. Again, a great paper. Now, cropping system in agriculture and the impact on soil health. Again, these are the areas where India could do quite a lot because there's a lot of work going on. So, in a pictorial way, I'm summarizing here, this is a monoculture system. No other thing, just the cereals. So you can see that here, soil-borne disease increased if you have wheat after wheat or wheat and maize. Soil erosion is increasing, nutrient use efficiency is decreasing, water use efficiency is decreasing, and biodiversity is decreasing, and soil functional microorganism is decreasing. Let us move out to a diversified system. In the diversified system, soil-borne disease is decreasing because you are rotating with the cereals, with the legumes and or oil seeds. Soil erosion is decreasing, water use efficiency and biodiversity increases, and soil functional microorganisms increases. So we went and measured all that, and I won't go into details, but if you look at here, these are some of the rotational crops. Then we went and took the DNA from the soil samples, and then we were able to see the functionality of those things. And then, of course, you can see the wheat yield improvement. This is a pulse wheat, and this is wheat. Big. So, again, as an agronomy people here, these are all done, but what we did was we went and had good hypothesis. We collected the scientific data, and we were able to get the DNA of the samples and show that the functionality, etc. So it's very interesting data. The other question people are asking, I'm coming towards the end of my talk. This is another interesting paper we published from work we have done in China with my PhD students, Agriculture Ecosystem Environment, Divergent Response of Deep Soil Organic Carbon Sequestration to a Large-Scale Revegetation. So we are asking people to plant trees, shrubs, etc. What's the impact? And this is a very interesting paper, again, recently published. So you can see this is the northwest of China, and you can see that rainfall ISO heights ranging from 400 millimeters here, and then all the way to 600 millimeters. And then you can see 300 millimeters rainfall ISO heights. And you can see here the total fine root length if you take the soil course, and here 0 to 6,000, and then mean annual precipitation rainfall. And you can see in the case of woodland, the fine root is more when the rainfall is low. In the case of shrubs, it's increasing. In the case of grassland, no change. So this is very important. If you're going to have carbon farming by planting trees, you need to take into account of the rainfall, and then you need to design what kind of species you want to grow. Again, the same thing here, it is shown: farmland, grassland, shrubland, and woodland. And then you have got the precipitation increasing, and this is in this case soil organic carbon storage, the total carbon storage. And of course you can see that as rainfall increases, in the case of woodlands, it's increasing. So if you go and plant some shrubs, it's not going to capture. So this is very important for revegetation purpose. Again, wonderful data. Then delta, this is the soil water change. Delta, this is the soil water. Then soil organic carbon kilograms. Everything is increasing with that. Now this is a case study from Australia. So we have three things here. One is crops, pastures, and the other one is orchards. Either it is fruit tree orchards or vineyard orchards. And you can see that, so in the case of here, the organic carbon increased from 1990 to 2000, so long-term experiment is about 0.11 per year. Then in this case it is 0.06, and this case it's taking long time. So the main message is that the soil organic carbon doesn't jump that fast. Depending upon the rainfall, depending upon the species, there is a limit up to which you can increase. After that, it won't. Equilibrium will be reached. He is a farmer, name is Simon. He did agriculture science from my university. I have taught him, and this is his wife. He decided not to work, and he's got a farm, and 8 kilometers northwest of a small town called Corrigan. And he has got farm size is 3,700 hectares, and that's about 250 kilometers east of Perth, the capital where I am. And he grows 3,000 hectares of crops, 1,000 breeding sheep, 280 breeding cows, and he gets very low rainfall, 280 millimeter average growing season, so very dry land and sandy soils. And you can see that he has got record from 4th generation farmer, 1911 onwards, rainfall is declining. So this is a climate change is happening. So he has concern, and he formed a group called Climate Concerned Farmers, and they're taking action. So what is he doing? He goes in and monitoring all his farm. He's looking at the soil moisture, then he's looking at various technologies, for example, soil cover, wide rows, narrow rows, machinery comparisons, sowing early versus grazing, chemical fallow, all these things he's looking. And he's also monitoring what we call yield monitoring. So when he harvests, it automatically monitors the yield. From there, he can develop a yield map based on soils, etc. And then he's got his cows, and he's got what we call brown manuring, and so on. So what has he found? Average year whole farm, his farm, emits about 2,165 tons of carbon dioxide equivalent per annum. This is a farmer who is estimating. In the case of that, cropping is contributing about 1,079 tons of carbon dioxide equivalent from the 3,000 hectares. But the livestock is contributing more, 1,286 equivalent from 400 hectares. And then he can find out what is the breakdown. So he found that carbon dioxide is this one, blue, then 41% is methane coming from his animals, and 39% is coming from nitrous oxide, fertilizer. So whole emission, breaking down which component is contributing. Then he's looking at on his farm, electricity, crop residues, fuel, all those things. Then this is the methane one. So he found that this is the total emission. What can he do? That is the next question. For example, part of his farm is not really productive. You cannot get year in, year out good crops. So he decided to use that marginal lands with some shrubs and fodder species, which supplies feed materials for the animals, but also they permanently store carbon. So he reduced that. And then he looked at legumes like vetch and lupins, more efficient fertilizer application, banding liquid fertilizer, solar for electricity generation on the farm, feed additives for livestock, electrification of the farm machinery, low emission fertilizer, slow releasing fertilizer, more legume options. So he wanted to achieve zero by 2030. So there are farmers who are already taking that. Based on very simple practices, it can be done. Now, a few more slides about the farm. This is my farm, or my university farm, which I look after under Kamsamana, 1,600 hectares. Again, you can see that this is the aerial map. So we have got the wheat and canola production system. Then we have planted quite a lot of shrubs and trees here. Then we got livestock, which is pastures and livestock, then wheat, etc. So our students are working on 8,100 sheep, 620 hectares of crops, 190 hectares of trees and shrubs, 17 active research projects. So students get an understanding of what are the practices in a large scale, not in a small scale. So the idea is that we wanted to develop practices to the best solutions for resilient farming system, environmental stewardship, and community engagement. And so, for example, here it is a researcher showing one of the shallow, low-lying areas where they're having some perennial trees and pastures. So the main strategies: mitigation on farm greenhouse gas emission, adaptation for climate change, profitable, ethical production system, because we need to have an ethical animal production system. And we also, for example, these are some of the ancient grass trees in Australia, millions of years old. So we're protecting that on the farm. Restoration of ecosystem and biodiversity, and education, community engagement, capacity building is happening on the farm. So how can offset carbon? People ask. For example, a lot of people in the city is emitting. So carbon offset is the basis by which greenhouse gas emitters neutralize the impact of their emission. Carbon offset cancels out carbon emission to some extent. Any business, for example, in Connaught Place, may buy carbon offset in the form of tree plantation that absorbs the amount of carbon the business releases. Conclusions: carbon dioxide resulting from industrial activity is a major source of greenhouse gas emission. Carbon sequestration in soil is an important strategy to manage climate change resulting from greenhouse gas emission. Stubble retention enhances carbon sequestration. Applying organic amendments including biochar, compost to agricultural land increases carbon storage. Carbon enhances the physical, chemical, biological fertility of soil, thereby increasing agricultural production. Adopting sustainable management strategies to increase carbon under tropical environment. And more importantly, developing analytical techniques to measure the increase in carbon resulting from carbon sequestration technologies is needed. Currently, it is very time consuming, so you need a new method. Finally, you got problems: fossil fuels, climate change, these are all problems. So less rainfall, I showed you, increasing temperature, finance sector is worried about it, and also you have consumers are demanding they need low carbon footprint products. But we have got plenty of solutions: carbon farming, reduced fuel emissions, agriculture marketing and advocacy groups, then traditional knowledge from indigenous communities. Then we can have carbon neutral agriculture, climate policy by the government, climate literacy, we need to inform the public about it, research, development and extension, biodiversity and restoration of the natural resource base, and diversified regional economies. Thank you very much. We'll take some questions. Students must ask questions. Oh, professors can also ask. Yeah, there's one student. Tell your name and what year you are.
Hello, sir. Good morning. My name is Aditya and I'm a BSc Agriculture student, first year.
First year.
Actually, I want to ask something about nano urea, what it is.
Nano urea. So, nano urea, nanotechnology is, so the urea is basically nitrogen largely, and that then into, you can deliver that through normal application. The problem is that then you will got volatilization, loss, nitrous oxide emission, etc. Whereas nanomaterials can be precisely placed and then can reduce those loss, and efficiency can be improved. It can be applied through the foliar or through the soil system. Yeah. So in a very micro way it can be available. So that's a good technology, can be utilized for the fertilizer use efficiency. Very good question.
One more question, please. Raise your hand.
Yes.
sir. I Manishankar
Yeah, we can hear Manishankar.
from BSc Agriculture, second year.
Second.
Sir, what is the opportunities in this topic for Western countries? क्या opportunities for Western countries में इस topic को लेकर?
For students, yes, everyone got opportunity. A lot of these areas we have PhD students and master students on any aspect, modeling, soil amendments, economics of it, agribusiness of it. So it's going to be an important topic, the whole science. So I was trying to show the science behind, not just about the last bit. So there's a lot of, if you're a soil scientist, soil researcher, then you can. If you're a plant researcher, look at the photosynthesis and so on. If you're a soil biologist, you can look at that. If you're an agribusiness, agriculture economics, what is the economics of it? Then you can look at the atmospheric emission, the total emission. So that's a climate change aspects, etc. So it's a huge area which has got huge potential, opportunities to do studies, specialization, PhDs, masters, and so on. Yeah, not only in Western countries, but also in India too. When I was a student, probably I didn't study, but I had to good study on soil chemistry, fundamental plant physiology, genetics, etc. So now, being a professor, I can quickly get immersed in it, but I had the basics. So basic chemistry, basic physics, basic mathematics, basic biology, all that put together. That's what it's all about. So a lot of opportunities. Yeah. And a lot of new papers are coming, textbooks are coming. You can just Google and find out. Very good question. Ladies, no asking?
Sir,
Yes.
sir, is it like carbon sequestration isn't cost effective or not? Do you think?
Yeah, so
Biggest challenge.
yeah, it is a good question. So the cost, what is the cost? The cost we are paying is that the globe is warming up. Climate is changing. We'll have disasters. So if you immediately look at the cost for a short period, it may not be beneficial, but the benefit I have been showing is that if you do the carbon increase organic matter, it increases the yield and productivity. So we are not sacrificing. If you are planting trees and the government is paying for that, someone has to pay for it. So what they call carbon credit. So we are not putting anyone out of pocket. Eventually, we are able to capture the carbon, greenhouse gas, and we all can live, not only us, but our generations. We're talking about IPCC 2050. I don't think I will be on the planet, maybe finished. 2050, 2080, 2100, etc. If you don't do these things, we won't even have a life. So the cost in that terms, then we look at the immediate benefit, and that's where the government has to come and intervene and provide support to people who are practicing that. But generally speaking, it is profitable. Yeah.
Sir, actually I want to know regarding the carbon credits, and mainly as in COP28 our Prime Minister mentioned about the green credit. So what is actually work, how the trading works actually in that?
So basically, let us say that one is, let's take Tata Steel or something. They are emitting, or I don't want to say Tata is emitting, but emitting. But they need to have a responsibility to offset that. Now, you and I are farmers in Gurgaon or somewhere, and we're going to have some trees and other things planted, etc. But we need to get the credit because we are not going to get profit immediately if I put 1 hectare of etc. So that's what called crediting. The other one is that if the farmer changes her or his practice to do some of the things I mentioned than normally done, and then show that it is sequestering, it is getting carbon stored. So for example, in Australia now, the government has introduced per hectare basis, if you do this and this, etc., there's an auditing going on, and people like me have to certify that independently. They get extra money. So their farm is going on. The farmer which I showed, for example, is doing some of the things and scientifically can show that it is storing carbon, then the government is giving some money for that. So that's carbon crediting. So It will come. I think in Europe and other places it's happening. India, it will take time, small farmers, etc. But it will come. It's basically emission, storing. How do we balance out? Who does that? How do we give them a credit? So, in terms of money. In simple terms, yeah. And there are policy changes to occur for that. Yes, now Professor Sharma.
Ahmed,
Please.
out of all these things, I think it is the climate literacy
Yes.
and informed decisions. They are very, very important. I keep them. From not only from the point of view of the farmers, but also the consumers. Now the concept of flexi diets are coming up. You know, livestock, Professor Kadambot mentioned, I mean, it's the biggest emitter of potent methane. And many of the developed countries, they are the biggest consumers of the
Meat.
non-veg
Yeah.
food. So we have to, as a consumer also, we have to be aware that what we are eating, how much carbon footprint it is leaving on the planet. So all these things, from the childhood, it has to be inculcated in the minds of our children, that whatever they do, how it affects the planet, which we are going to leave. So this was just
Good comment. So here, for example, the consumer, that comes in because at the end of the day, all the food produced is consumed by city-based people. And they probably doesn't know where the food is coming from. And we cannot stop food production. Food industry is the largest industry in the world. And it will continue to, as the largest industry forever. Because you need to have at least minimum 2 meals, but many of us take 4 meals. And this will continue. But how do we produce food in a way it is palatable to the planet? And so you are absolutely right. The cultural shift, educational curriculum, school killed. I think we are seeing now, the plastic, for example, many of the hotels we are not seeing any plastics at all. Plastic pollution, how we do that, reusing, and those things will help us. I'm sure that the technology is developing very rapidly in many areas. Don't underestimate the power of technology, but we have to do 2 actions. One is mitigation strategies, the other one is adaptation strategy. Time is running out, that's what it's all about, but we can't say India will be okay, Australia will be okay, no. We are all in it. And wasting food is a big one. 30% of the food in the world is wasted. But if you calculate the energy, the carbon emission of that food to produce that, but only know that when you put it in the landfill, we have now a project to look at that. How much is emitted from the landfill? Huge amount. Both CO2 and methane.
So I have one question.
Please.
Sir, actually, when you talk about the analytical approaches, so can we use machine learning and deep learning in calculating any other approaches?
Yeah, all these things, I mean, it's all numbers and everything, etc. And then, of course, we're talking about what will happen in 50 years, etc. So these are all based on models. And people say, oh, but that should be based on biophysical modeling, biophysical and economic modeling. And of course, AI can be used in many of the things, not only predicting, but also to develop technologies to combat that. Yeah, but we still need a basic understanding. If you don't have a basic understanding at an undergraduate, master's level, then we will not get, I mean, you don't need to understand everything, but as a soil science student should understand what is carbon, where it is coming from, how it is released, what are the factors it affect, rate process, and then of course machine learning and things can be used. Thank you.
Sir, you discussed a lot about the Australian scenario of how they work towards reduction of carbon emission, but I have seen many of your posts and you are very frequently visiting China.
Yes.
And since we can relate with the China in terms of our population, Can we have some solutions from there, like what they exactly do and which we can implement here
Yeah.
in India as well?
A lot of the papers I showed is coming from China, so you can see that. So I've been, thank you, Usman. I have been going to China for the last 20 years, and I have trained, I just lost count how many PhDs I have. At the moment, I have 40 PhDs in 3 universities, co-supervising, but main professor is from China. I have intensively traveled interior parts and agricultural parts. China, the main problem has been like India. In fact, it was below India. 1947, India got independent. China became republic in 1948 because of the Cultural Revolution. Their republic, and there were really 34 million people died for various reasons, starvation. Now China produced 650 million tons of grain. India best production was 382. I think this year is low. China has got only 9% of the arable land. They got 20% of the world population. So India now just taken over. India has got better land. And they were using and misusing a lot of fertilizers because of like in India, subsidies and so on. Now the government came and said that fertilizer use has to be reduced, emissions being monitored, green production system, hybrid rice technology, vegetable production system, many things that are environmentally concerned. If you go to Beijing, I was there a couple of months ago, no pollution. Whereas previously pollution. So solar, they are the world leaders in solar panel, including what we get here, and even in Australia. A lot of green technology, and then of course plant science and crop science is advancing, animal production. So they are really moving towards. Then there's a lot of vegetation, revegetation of marginal lands in a massive way. You can implement things very fast, whereas here it is still difficult because we got the democracy means you can stop, roads cannot pass here, people, political influence. So in summary, what I'm saying is that China is feeding their population very well. They're exporting, they're importing some. Their technology is rapidly advancing. Only country in the world putting money into science and technology research, increasing is China. United States going down. My country, Australia, has gone down. India has gone down. Now take agriculture R&D. Only country in the world increasing R&D investment is China. And huge amount of students they send overseas, despite they have top universities, for 2 programs. One is called China Scholarship Council program, full PhD, selected universities, and they send, I just got this year 8 of them. So their scholarship is covered by the government. Sometimes I wonder why. They have got better universities there. Second one is as part of the PhD program, they can go up to 1 or 2 years. So last night I accepted 2. So they will, PhD is from China, but they will come to my lab, spend 2 years, as part of the PhD, produce papers, etc. They go back. So huge amount of investment. They're concerned about environment. And people say, oh, the pollution. This was the case with Europe. For example, Boston in the United States, if you go in the 50s, it is all steamboats and things come and pollution. Now Boston is beautiful. So China will do, and I'm sure that India can do if we have the right act. Amazing country. And students was an issue, but that's all changing rapidly. Very good.
Good morning, sir.
Yeah, good morning.
This is Varshita from BSc first year. Developing these cropping systems and everything, so we need to bring awareness among the people or farmers. Sir, as a student, it's our responsibility, it's our duty to learn how to gain knowledge about this. So we can gain knowledge on this, and as the professors and scientists, you can develop many cropping systems. Sir, as per your perspective, how to bring awareness among the farmers on this?
Very good question. So it's always the extension part of it. Translation part is so important. Even all the undergraduate program, I'm sure that you will have interaction, good communication, demonstration of the best practice, working with the progressive farmers, because all the farmers are not the same rate. Like students, some are very fast learners, some are middle, some are low. So what we do and what India has done is the same, where you demonstrate the best pet packages and work with the farmers, not just in the lab. Lab is important. All these things, things which I showed is very simple things, but put a science in it. But working with farmers, extension agencies, KVK, and so India is a world leader in that, so as China and Australia. And only way is that we work with the farmers, understand their problems, and then work with the solutions. And the farmers are the best integrators in the world. They integrate everything. So whereas we, dividing universities into, I was talking with Professor Sharma and Saktay, that just it is integration. Whereas farmers are the best integrators in the world. They have to live on the land, they have some fish, they have duck, they have chicken, sheep, goat, crops, and then they are facing the climate change every day. So we learn a lot from farmers. Same, you guys need to learn, spend time with them, work through them. But there are agencies in India doing excellent job, and both government and non-government agencies. And you got 250 million farmers in India. And they are all small farmers, not large farmers like Australia. Any other questions? Very good. We'll take a group photo sometimes with the students. But I wish you all the best. Very, very good, important area, agriculture. Don't think that medicine is the only way to go. I lost admission, as in a YouTube somewhere. I said that admission for medicine for 6 marks. I was very unhappy. Then I ended up in agriculture. And if there is another life, I will continue to work in agriculture. Thank you. Go down. Yes. Sit there. Or?
Yes, sir.
No, you can come here. Yeah. Thank you very much.
Thank you so much, sir, for your wonderful presentation, and your presence have elevates our gathering, and surely our students will incorporate your insights that will undoubtedly set our academic path. And sir, though we all are agriculture, so we know that the best method like crop diversification is one of the most important. Even in the horticulture and even in the agriculture, we have studied different crop diversifications like crop rotations. Rather than doing the sole cropping or the monocropping, sir has suggested that different cropping systems like relay cropping, strip cropping, they are much more advantageous in stabilization of the carbon, which is also known as the carbon sequestrations. So adopting the right methods of adaptation and mitigation strategies will be one of the best phenomena for the climate change. At least some of the carbon emissions will also be reduced. And being an Indian, we all know that we generally burn the stubble. But from the sir paper, we come to know that if you retain the stubble, there is a reduction of 528 per hectares per year of carbon emissions out there. So my dear student, let's hope for the better futures, as you will be the youngster, and even myself, we have to be shaping the futures. So once again, I would like to thank sir for sharing your wonderful wisdom with us. And I may now request our respected Dean Professor Sahadev Singh to present memento as a token of appreciation to Professor Siddique. Everyone, please give a round of applause. Thank you, sir. May I please welcome Dr. Usma Manjur, Associate Dean, School of Agriculture, for word of thanks. Ma'am, please.
Good afternoon. Honorable Sir and faculty members and their students. So thank you so much for accepting our invitation. I would like to mention that Sir had come for an international conference at Indian Agricultural Research Institute, New Delhi. He stayed there for 3 days and he ensured to be present amongst us today, and for that he delayed his stay in India by 1 day. We are greatly thankful for that, sir. For our students, I would also like to give a brief introduction about Sir. Though from the slides and from the work Sir has done, it speaks volumes, Sir needs no introduction in that case. But I would like to emphasize that Sir has more than 30 years of experience in agricultural research, training and management in Australia and overseas. He has a national and international reputation in various aspects of agricultural science, including crop physiology, production agronomy, and others. The most outstanding achievement of Sir has been the promotion and development of agricultural research and education amongst agricultural stakeholders. You know what we as researchers do, we research, we do our research, we publish the paper and we forget about it. But what Sir has done, Sir has disseminated that knowledge to the stakeholders. It's a huge respect and regard for that. I would also like you people to know that Sir has won the Western Australian of the Year award in 2014. Sir has won the Friendship Award of China, the highest award China gives to a scientist from abroad. And latest in the box full of awards is the Scientist of the Year 2023 from Western Australia State. Been the highly quoted researcher of the year, not just once but many times in his career. On behalf of School of Agriculture, Galgotias University, and on my own behalf, Sir, I thank you for being here with us, sharing your valuable insights on such an important topic. We look forward to work in this regard, and we hope to make you proud one day as Indians. Thank you so much. I would like to thank Professor Kusumakar Sharma. Sir always takes time to be present with us and always encourages us. Thank you so much, sir. I would also like to thank Professor Gaur. He is not here with us today, but he was not well. But I would like to thank him for giving us an opportunity by inviting Sir and making this event a success. I would like to thank our Honorable Dean, Professor Sahadeva Singh, sir. He is the man behind the scenes, on the scene, off the scene, everywhere. We thank you, sir, for your great support always. Thank my faculty members, my support staff from IT. I thank the members from media department who have captured this event wonderfully on the YouTube. And last but not the least, I thank each one of my students from the bottom of my heart, irrespective of your exams going on. You took time to hear, sir, and being here. Thank you so much. It means a lot to us. Our good wishes to all of you. We'll take a group photograph. All of you can stand at your respective seats and we can have a group photograph, or you people can come here. That would be better, sir. If the students come up and we can stand. I think we can. Then, outside. Okay, sure. Outside. So we'll rise. It's okay, I think we can start on our own. Yeah, please.
can take a photo from there now? See how it goes? Can you get everyone? Maybe not. No?